All right, guys, it is frame time. So, guys, this is part two of the frame build. Now, I thought it would be kind of silly if we didn't actually build a swing arm. So, this video is actually going to be focused on doing a billet swing arm. I don't actually know of any billet swing arms that have been done for the TRX250R that are bolt together. It's not easy, guys. This is going to be a little bit lengthy of a video, but yeah, we're going to take our 18.5 eye-to-eye swing arm that we currently fabricate in-house, and we're going to turn this thing into billet. It all started with a 3D scan, and now we're getting it into Fusion, and let's start drawing. So as you guys saw in the last video, it all starts with importing the mesh into Fusion. Now again, this thing is kind of just floating in space, so I have to actually get it aligned. Now, as always, I'm going to get this thing centered up to the origin, and I'm going to actually start drawing the pivot tubes. Now, these are going to be all rough measurements. I'm just going off the scan. I did a low resolution scan because I was a little bit in a rush when I was scanning it, and it was also already powder coated, so it's actually harder to scan in anything that's powder coated or painted. You generally want to have like a flat sandblasted finish, something that's not glossy. You definitely don't want metallic, which I had when I was doing the scan. So you guys will see the poor quality of the scan. It's definitely not the best, but it's actually plenty good enough for what I'm trying to do. I'm just trying to get this thing kind of modeled up, and then I'm going to take some real life measurements in real life and transfer all that stuff into the computer in the end. But in this video, we're going to get everything about, I'd say, like 95% accurate, and all the final work will be done at the end. So right here, guys, you can see I've got the pivot tube already drawn in the front. I actually dragged it over to the rear just to see if the swing arm was aligned, and it wasn't. So I'm going to go ahead and just rotate it on the front pivot. I think I went about half degree. I think 0.5 was about, yeah, 0.5 was what we needed right there. Now I'm actually going to turn this tube into a carrier housing because I already got it centered up or close enough for what we're trying to do here. It's good enough to work with. All right, guys, back to it. Now again, this stuff's kind of just coming out of my brain and off the scan. So right now I'm drawing the side of a swing arm tube, and you're gonna see this is not gonna look pretty. I mean, it's gonna look very boxy. It's not gonna look fluid. There's a lot of tweaking and adjustments that we have to do in this video. So it's kind of cool. I mean, follow along. You guys are, I guess, getting a behind the scenes look at how I would actually tackle something like this. It's also the first time I've drawn a billet swing arm for an ATV. Obviously, we've been doing all the big wheel stuff, which is something I've been spending about the last year on getting dialed in. Now, the reason I'm going bolt together on this swing arm is because welding sucks. I'm not gonna lie to you guys. The lead times are just always astronomical with any kind of welded parts. Welds will crack. You're always gonna have pulling issues. There's gonna be heat issues. Anytime you weld, there's a heat affected zone. So having a billet aluminum part that's actually bolted together is going to be pretty sick. And to be real with you guys, this might not work. I mean, it might not hold up, but I'm willing to take that chance on this this custom build. Again, I see what Yamaha did with the YFZ450R frame with the bolt together design. They're super reliable. I don't see why I can't work on a swing arm. It works on all of our big wheel swing arms. It works on our pit bike swing arms. A lot of guys actually do it in the motorcycle industry too. If you take a look at the Harley industry, a lot of the Dynas and all that stuff, they all do custom billet bolt together swing arms for them. So anyway, guys, I'm rambling because there's really not much to talk about other than just watching me draw lines and adjust chamfers and bevels and all kinds of fun stuff. But yeah, so right here, guys, you can see the swing arm is starting to take shape. So I'm actually going to do a mirror and flip that thing over to the other side so we can kind of, I guess, eyeball it and just see if it's looking right. Now, I want this thing to look fluid. I want it to look similar to the welded part. I don't want it to look like it's not right. You guys remember the old OG Cannondale frame, how boxy and overbuilt that thing was? That thing just rode unbelievably stiff. And that's something that we don't want when we design this swing arm or this frame. So we're going to have a lot of pocketing, a lot of material removal in certain areas, so we get a little bit of flex, and that's going to be very hard to mimic with a bolt together swing arm. Let's be real. I mean, we've been welding swing arms in the ATV industry for years, and yeah, I'm looking to change some stuff, guys. I'm bored. Again, I've learned so much with the big wheel kits and all of our bolt together swing arms that we have for those, that I want to take all that technology and all the learning that I've been doing the last few years with that, taking a welded part and converting it into billet, and I want to bring that over to the quad stuff. I think the quads need more updates. They need more technology. It's unlimited in my opinion. Like everything that we can do in house, it's completely unlimited. So anyway, guys, you can see right here we're working on the carrier housing, and again, I'm just pulling and press pulling and tweaking, and I'm adding material, I'm subtracting material. So like right there, it doesn't look like it's the right length. So I'm kind of just going by eye right now and getting this thing dialed in. So we're gonna round the corners off. And again, we still have the scan, but you can see I'm not really turning it on because I'm kind of just going off what I want to see on the swing arm. So right there, I'm kind of mimicking where a weld would be. I'm adding a little bit of strength right there. All right, so I'm pretty happy with that. I think it's starting to look pretty good. Now, after changing the angle of that carrier and getting the pinch plates at the angle that I would like, I'm sitting here going, well, we're not welding this to the tubes, so this has to be bolt together. Now, imagining this thing just being a big rectangle when I machine it, and I'm just gonna have these two pieces that are gonna be sticking off of there. Now, we're gonna do a combination of 5-axis and 3-axis CNC machining when we make this part. It's gonna have probably a slitting saw to cut the slit in the pinch plates. Obviously we're going to bore the inside out, and the cool thing about this is the tolerance is going to be super perfect. Being that we are CNC machining it, it's probably going to be the roundest carrier ever made because you're not welding it. Now a lot of the OEM ones are cast aluminum, which those would obviously have a perfectly machined out carrier housing too. But my goal here is for an OEM type fitment, but with the strength and the reliability of the billet components. We have the option of 60-61 or 70-75 aluminum. Now I had one guy actually commented on the frame, and he was saying, hey, why don't you guys use some titanium components? And that's the cool thing about what we're doing. I mean, any of this stuff can be converted into any material. So obviously we're not going to go steel because we're trying to get away from that. So we have the billet aluminum, and then yeah, guys, we could go titanium. That's a whole other learning curve. It's a whole other tooling cost and setup time, but it can be done. So it is really unlimited in terms of the materials. We can make this thing as heavy or as light as we want, and the goal here is to be lighter and stronger than anything that's been made. So I'm pretty excited to experiment with it. So I kind of jumped ahead here because I won't lie to you, I'm going to say 4 hours into it at this point. You guys are probably seeing about 25% of the footage. I also have this thing in fast forward. I took a lot of breaks. I took a lot of just back and forth thoughts, looking at pictures of my quad, pictures of my current swing arm, and yeah, just bouncing around trying to figure out my next move. So I've got some cross supports in here with some pockets on each side. Now just imagine, if you look at our big wheel swing arm, I'll have to possibly insert some clips in the next video, but we have everything bolted from the side with pockets. So those cross tubes are actually going into a pocket. There's going to be dowel pins, and right there you can see it's 194 ounces. I believe that's around 11-12 pounds, and I haven't really removed any material yet. I've done 2 pockets on each side, which we're not doing so bad. So again, we're starting off with just getting it going, and it's unlimited for what material and how much removal we want to do for saving weight. So now I'm going to just go ahead and add some holes in the back for the pinch plates. And again, I'm just kind of going off whatever the heck I want, guys. I'm keeping it obviously similar to what we've been doing on our carrier housings. I like the look of those. The only thing I'm trying to figure out is how I'm going to get the old BVC tag on the back of the carrier housing, being it's rounded. So that's going to be some crazy 5-axis machining and engraving, but I've got to have that on there because I'm proud of showing that off. And yeah, guys, we warranty all our parts, so if it has my name on it, there's going to be a warranty on the part. And I just remember buying many parts over the years as a young kid when I was saving up to race my quad. Man, it sucked when I broke a swing arm. I've pretty much snapped every brand on the market, and nobody ever helped me out. So if anybody's running my parts and you have a damaged part or you need help, I mean, we generally warranty it, guys. that's just that's how I want to be as a business owner, and I want to take care of all my customers. All right, so here I am. I'm staring at this thing. I'm going, how the heck am I going to mount this chain guide bracket on here? So I want this thing to be bolt on, because if you ever break it off or you ding it or smash it, I want it to be replaceable. And that goes for every part on this swing arm. So if you break a side tube, a carrier housing, something just cracks. Being that this thing's going to be a multi-piece swing arm, it's going to be 100% replaceable. That doesn't mean you have to mess with the whole swing arm. You can literally take it apart, unbolt the piece, and put it back on. Same thing with our big wheel kits. So we used to ship those things out, and I can't tell you how many times I've had UPS just destroy our boxes. And I've had pivot tubes get dinged. I've had chain guard mounts get bent. I had it unfortunately happen on my second billet swing arm order, and it was actually really cool because the customer said, "Hey guys, my box got smashed from UPS." And when he got it, the swing arm was sticking out the side of the box, and I said, "Shit, you only need a pivot tube." So I cut a new one for him. I had it sent out the next day, and he was off riding again with no issues. Didn't have to send the swing arm back. Didn't have to worry about anything. And if he ever has any issues in the future, we can just replace the part. So 100%, that's my goal with these quad swing arms and this frame. I just want everything to be replaceable on the shelf, or if it's not on the shelf, we can at least machine it within a short period of time. There's not going to be any lead time with that, and that's the goal, guys. So again, I'm going to keep on rambling while you guys watch me draw this swing arm, and hopefully you guys are learning, I guess, how fusion works. I can't really do a deep dive on every nitty-gritty aspect unless I started doing an actual training class. So if that's something you guys really were interested in, I mean, we could possibly look into, anybody that wants to get into the trade, wants to learn fusion, machining, any kind of manufacturing stuff. I mean, it's something I love. So if it's something you guys are interested in, definitely let me know. I'm sure we could do maybe a separate channel on just training about how to use this program. But I really am trying to show you guys in these videos all the behind the scenes stuff, and you can definitely see like how I'm doing stuff. And I wish somebody was showing me this when I started out. I had to learn the hard way. I had to watch hundreds of videos. I had to talk to industry experts. I had to learn from people, and it's how I learned how to do all this stuff. But it's definitely a blast drawing these parts up from nothing. It's a lot of fun. It's cool to, I guess, document it. And to be real, I never really had the idea that you guys would want to watch this stuff. I don't know why. I just kept posting build after build after build. It was kind of like the channel's been on repeat. And to be real, I actually got tired of posting the same stuff. So I can do videos like this on every build moving forward, and kind of just makes it fun for me, because this is why I do this stuff. It's what I enjoy. So if you guys enjoy watching this, then let me know in the comments, and we'll keep posting it. Well, I'm happy with how that's looking. The only thing I want to do is actually cut a pocket on the side of the swing arm tube. That's going to allow this thing to actually sit into the tube. So I'm drawing a sketch on the back side. I'm just press pulling it through to basically cut some material out, and that allows this plate to sit into the swing arm tube. Now, once again, I'm actually taking what I learned from the big wheels, and we're going to do a linkage tab that bolts onto the cross support. So I'm basically going to draw something that kind of goes in a U shape around the center spine. I'm going to call it the center spine on this one. Now we're going to have two 10mm bolts in the front and 2 in the back with tapered heads, and it's going to be self-centering as you tighten it. Now again, if you break off a linkage tab, or maybe something gets smashed while you're riding, all that stuff's going to be replaceable. So there's that U shape I've been talking about. I'm going to actually put these pieces together, make them all one piece. All right, so now that those are combined, I'm going to go ahead and draw the tabs on it. I'm going to do that from the side, and again, this is where you're really going to see how bad the 3D scan was. But again, I'm going to take measurements, and all that stuff in real life, and it's really not a big deal. Everything actually turned out pretty decent for how fast I did the scan. All right, so here we go. Let's turn that mesh back on. I'm gonna go ahead and try to find center on that awful looking mesh. Like I said, it's a little bit rough, but it's okay. So once the center hole is drawn, we're actually gonna pull center off that again and draw the outside dimension of the tab. I'm actually gonna go back to the line tool. Now we're gonna draw the tabs on there. Now what I'm gonna do is I'm actually gonna go all the way across this part with the sketch. So we're gonna press pull that all the way across until it's solid. And it's just easier to do it that way. You can go back at the end and cut your center gap for how wide your linkage is. So right here you can see I didn't go all the way just yet, but I ended up deciding on going all the way. All right, so there we go. That's the view I was looking for. So now we're going to take a dimension. We're going to draw a rectangle. We're basically just going to cut the center of that out off of center. And that's going to allow me to do a clean cut, and I'll know it's perfect. Also eliminates any kind of measuring from each side. It's just faster to go off center line and make it perfect. Now, I'm not 100% sure on how thick these brackets are going to be. I might possibly do some inserts on them. We can do a stainless insert. We could even do a titanium insert. Now, that's going to stop any kind of egging out that's going to happen on the holes. Obviously, aluminum is a little bit softer than steel. But again, all the OEM manufacturers for the motocross bikes, to this day, they don't have any inserts on theirs. Now, this is something that we've done in the past on like our Honda Talon trailing arms. So we did do stainless inserts on all the mounting hardware, but that's also on a very heavy UTV. Now, just in case I decide to do the stainless inserts, I'm just going to show you guys how I would draw it. So basically this would be a press fit into the hole. Now we would have to actually oversize the hole and then undersize the insert down to the size of the bolt. So basically I'm just going to draw some circles. And again, we're going to make a separate component, and it's going to basically be whatever material we want. That's the beauty of designing and making your own parts. It lets me just be super creative. Anytime you press pull and fusion, it wants to automatically default to a join. You don't want to join that, so that's going to be a new component. I want that thing to be a separate body from the linkage tab. So right here, I'm having a hard time with it. I think my brain was fried at this point. I was like, all right, it's time to stop and take a break. But I kind of just kept going. I wanted to show you guys this one last part. All right, so finally, I'm gonna go ahead and turn the linkage off, join those two pieces together, turn the sketch back off, give this thing a nice little chamfer. You guys can see how many sketches there are on the left as I'm scrolling. It's unreal. I mean, at the end of this frame and swing arm and A-arms, I mean, we're gonna probably have 1,000 sketches, if not more. It's pretty wild. So yeah, there's the insert if we do go that route. Now, if for any reason I can't make those tabs as thick as I'd like, I will definitely add an insert. So let's put this thing back together. Now, I haven't done any bolt holes yet. I'm gonna do that last. So I'm gonna 100% make sure this drawing is perfect, make sure it's how I want it, and make all my bolt holes last. But yeah, man, this thing is looking cool. So let's hit the save button and let's see what it looks like on the frame. God, that looks awesome. I think I'm more excited still for the A-arms, but I'll show you guys a little preview of what I've been doing on the frame. Now, I can't for the life of me decide on narrow or standard. I might have to do both, but to be honest, it would be easier to go narrow on the frame. If I want to do a narrow frame with the +4 A-arms, it's not hard to do. But yeah, guys, looks great. I'm getting excited. So stay tuned for the next video. We're definitely going to jump back to more of the frame stuff once I decide how wide I'm going on the frame And hope you enjoyed. Leave a comment. Definitely subscribe to the channel and hit that like button. It really helps these videos get out there. And if you want to see more CNC machining stuff and more fusion, let me know. And we'll see you in the next one, guys. Thanks for watching.